But what we need, look, what we need here is what we've needed in every other problem we've done. We need an equation with R and H in it, don't we? Other than the volume equation, because we already have the volume equation. Anybody see this? No? By nobody answering me saying they see it, I take it as this one. It's not obvious here, right? The equation.
I don't know, but if I can get on that page, we get the volume of the sphere, and set that equation equals the volume, and that's the volume for R, the volume for H, or something. I don't know.
Okay, that's so you're thinking I can figure out what the volume of the sphere is, and plugging that in for volume right there for V. The problem with that is the volume V, right? That volume V is the volume of the cone, and so there's no way that cone can ever have the volume of the sphere, right? Because it's inside of it. It's a good, I mean, you got to try something here, right? Okay, how about bonus points for anyone who can come up with an equation relating R and H together right now? Well, I just want to make sure, like, everyone in here convincingly does not know how to proceed with this. The volume has R. Yes, okay, good point, but it's not going to help us. This is the objective function, okay? This is the objective. We can't use the objective as our constraint. The constraint has to be some other relationship between R and H. Okay, so we'll proceed. No, we'll proceed. Bum, bum, bum. All right, let me help you out, okay? Let me help you out. We'll see, we'll see. What is this? Just look at it for a second. What is it? It's a what? It's a circle and a triangle, right? Now don't get, I didn't mean to make it look equilateral or anything. There, is that better? Okay, so this is a circle with a triangle inside of it, isn't it? Now let's go back up and look at our picture. That was a cone with a sphere, right? Imagine taking a knife and cutting the sphere right down the North Pole, just right down the center, right? A cross section of that sphere cone thing we're making, right? You would then create this shape right here, correct? A and B. I need any relationship I can find between R and H. From where? Oh no, but we can't use this. Wait. Yeah, we can't use the constraint. I'm sorry, we can't use the objective. We can't use the objective because, look, what we're trying to do is, in the objective, we're trying to find a replacement for R or a replacement for H. So if you use an equation to replace itself, at the end what you'll get is something like V equals V, and that's all it's going to say. Look, let me take you the rest of the way, okay? Let me take you the rest of the way. Here's the center of the circle, right? Now, we know that the distance all the way from the center to the bottom of the triangle to the top of the triangle, right there, that green dotted stuff, which now I'll make it green solid, that is h, right? Agreed? We don't know what that is. Now, we also know that the distance from there to there is what? R, the radius. We do have a triangle. It's a right triangle. But that hypotenuse doesn't lend itself very easily to revealing what it is, does it? Because all you could say is it's the square root of r squared plus h squared. However, there's something that we haven't addressed, and that is the fact that the distance from the center to here is what? That's 1. And the distance from here to here is what? 1 also. Agreed? And what is the distance from here to here? That's 1. Agreed? What is the distance from here to here? How long is it from the top of the North Pole down to the bottom of the triangle? No, not from the top to the South Pole. From the top to the bottom of the triangle. No. From here to here is what? That's h. The yellow is h, right? This, the blue, the little blue, the highlighted blue right there, isn't that 2 minus h? Isn't it? I'm just like labeling every freaking thing I can here. I'm trying to come up with a relationship here. Huh? Well, I mean, I know where we're going. Yeah. But I'm trying to, like, when you're looking at these problems, you try and start to extrapolate as much information as you can from the picture. I see a triangle I really want to go after. It's right here. You see this right triangle right here? It has R in it. It has a hypotenuse. If I could just get that other side in terms of h, wouldn't I have a relationship? Right? So let me draw that, get that h out of here. That green triangle, that highlighted green one looks like this. This was R. This was 1. Yeah, it's this part right here, which is 1, right? That's 1 right there, all the way to the bottom. Take away how much? 2 minus h. So what is 1 take away 2 minus h? Negative 1 plus h? H minus 1? I mean, there's so many freaking ways you could see that. I think that way that I just showed you is way too complicated now that I look at it again. Right? So, peace out. Let me try a different approach. Just a quick one. Here's our half triangle. Looks like this. There was the piece we were looking at in there, right? We knew this side was h. We know this side is r. And then I came out from the center of the circle out to here, called that 1. So the distance highlighted yellow, how long is all of that right there? H. So if you want just the distance from here to here, it's h take away this much, which was 1. So h minus 1. Much easier. But see, that's the thing. On these problems, there's no like, okay, every time I see this, I will look at this relationship. No, you have to look at all the different geometry possible things that could happen and come up with your relationship. So here, this side now is what? H minus 1. Now do we have a relationship between r and h? Yes. R squared plus h minus 1 squared equals 1. Which means I can put r squared equals 1 minus h minus 1 squared. Do I need to solve it for r? Like, do I need to take the square root on both sides here? No, why not? Yeah, look back at your volume function. What's in the volume function? R squared. Beautiful. I have r squared, don't I? In terms of h. I don't know if beautiful is the word we would want to use, but try and get this in here. So going back to our objective function, it was volume equals 1/3 pi r squared h. We are now going to replace the r squared with our constraint, which is 1 minus h minus 1 squared, and then times h. Let's FOIL that out inside, expand it. 1 minus h squared plus 2h minus 1 times h. Just make sure I did that right. H squared minus 2h plus 1. Wait, hold on. What? Did I? Minus 2h plus 1. I'm not sure. What do you? Yes? Minus 2h plus 1. But I already distributed the negative through. Do you see what I'm saying? Like, I took this right here, and I figured out that was h squared minus 2h plus 1, right? But then there's a minus in front of that that would distribute to each one, which would make it the next line. And then the ones cancel, and then I distributed that h that's sitting at the end through. And I don't know if there's something just about me, I don't like the negative in front of the h cubed. So can I put negative 1/3 pi times h cubed minus 2h squared? That's my volume. In terms of a single variable, right? Questions? Can I move to a new page? So we're here. The volume is now in terms of a single variable h, right? It's negative 1/3 pi times h cubed minus 2h squared. Please check my brain has stopped working. Is that what I just had on the board a second ago? Okay, now what should we think about? Good, good. Is this a closed or an open interval? So our variable here is h, right? Is there a restriction on h? Absolutely. What's the smallest h could be? You could have a cone that went all the way up to the North Pole and just became a point, right? You'd never do it, but you could have it. 0 would be the smallest. What about the biggest? 2. Because that would make a cone that would get wider, and then at the very bottom it comes all the way. So it would just be like a line connecting the North and South Pole together. It had no volume to it. But we definitely have a restriction here, which is good. What? Uh-oh.